Hello everyone. In this lesson and in this series of lessons we are going to introduce you to computer programming through C. C is a computer programming language. These lessons are meant for someone with very little or no prior experience in programming. We are going to keep our assumptions really low. We will start with the basics and carry everyone along. Okay, so let's get started. Unlike most other machines that can perform a finite set of predefined tasks, a computer is a general purpose machine that can perform any computational task. All you need to do is you need to give it a program, which is nothing but a set of instructions to perform a task. A computer is nothing in itself without programs. All the tasks are performed through programs. A modern day computer would have hundreds and thousands of programs in it. There are programs that manage the hardware resources of the computer. We call such programs system programs. And then there are programs that perform your favorite tasks. We call them application programs, like a web browser that you use to browse the internet, or a text editor that you use to create a document. And if any of these programs cannot perform the task that you want to perform, you can write your own program. And that's what we are going to learn in this series of lessons: writing and executing your own program. As we saw, a program is a set or sequence of instructions that you would give to the computer, and the computer would execute those instructions. Now, in what language can I give these instructions to the computer? Can I give these instructions in a natural language, like English? You must have heard that a computer understands binary. Binary is the language of computers. But wait a minute, didn't I say that CPU that has to execute all the instructions will understand only machine language instructions? This guy is shouting it out loud here that I can execute only machine language instructions. So how can we write program in assembly language or whatever we are talking here? Well, you can write your logic in assembly language, and then you can pass the assembly language instructions to a program named assembler, and this assembler will generate machine language instructions corresponding to the assembly language instructions. So basically someone wrote a program named assembler, and with assembler programmers could write a little more readable instructions in assembly language. But there was a problem with assembly language. Assembly language is strongly mapped to machine language. It's just that some binary codes in machine language become keywords in assembly language. So just like machine language, assembly language instructions will also vary from one CPU architecture to another. So if you would try to port your assembly language code from one architecture to another, the same program may not run. You may have to rewrite your program according to a new set of specifications. So both assembly and machine language are specific to architecture of machine. Such languages, the instructions in which depend upon the architecture of machine, or more specifically the architecture of CPU, have been called low-level languages. There was need for programming languages that would not be specific to architecture of machine. Such programming languages were called high-level languages. A high-level language is supposed to have more elements of natural language, and it's supposed to make the life of a programmer a lot more easier, because he will not have to care about all the detailed low-level specifications of the machine. And now let's talk about high-level languages. High-level languages give you abstraction from machine architecture. So many high-level languages have been developed till date. I would name some of them. We have C. Finally, I took the name of C after so long. We have C++, we have Java, we have Python, and a couple of old ones like Fortran, Basic, and the list goes on. Fortran was the first high-level language developed by IBM. Now, even with high-level languages, we cannot skip the basic rule that finally the instructions that will be executed have to be in machine language. There are two possible execution models for high-level languages. Some languages are called compiled languages. For these languages, we would have a program that we would call compiler. Compiler will be different for different languages. It will also be different for different machine architectures. Compiler will take your program written in a high-level language. We typically say that it takes your source code written in a high-level language and generates machine code, set of instructions that can be executed directly by the CPU. C is example of a compiled language. How it typically works is that to the compiler you would give a file or a group of files containing your program in high-level language. Let's say app.c is the file that will contain your program in C. The compiler will generate another file that will be executable on the machine. Let's say it will create something like app.exe. Exe files are executable files on Windows machine. The process of generating executable files from source code written in high-level languages is called compilation. Basically, compiler performs compilation. There is another execution model for high-level languages. Some languages are called interpreted languages. For interpreted languages, we need to use programs that we call interpreters. Unlike compilers, interpreters do not generate executable codes that can be executed separately. An interpreter takes source code in a high-level language, analyzes it, and runs it within itself. No executable file is created, program is executed within the interpreter. We will not go into the details of how it really happens. Python is an interpreted language. Theoretically, any language can be compiled or interpreted, but practically languages fall into one of these categories. Either they are compiled or interpreted. So there are so many high-level languages, and we are saying that we will learn programming through C. First of all, why there are so many languages and which language is good? Actually, there is no good or bad language. Some languages were written to overcome the limitations in previous languages. Some languages were written to make a certain set of tasks easier. But as such, basic constructs and primitives are same in most languages. And what you can do in one language can be done in another language. There would be very few exceptions. If someone knows one of the programming languages really well, it will be very easy for him to pick on another programming language. And now let's talk about C. C was developed around year 1970 by a great computer scientist named Dennis Ritchie. Dennis Ritchie is also the creator of Unix operating system. In fact, Unix operating system was written in C. C is a high-level language and it needs compilation. C is still a very famous programming language, and most of the other famous programming languages like C++, Java, or C# derive their basic structure, derive their basic constructs from C. So if you know the syntax of C, it's really easy to onboard these other languages, at least for the basics. And C gives you a lot of low-level control on machine. Some people say that C is somewhere in between a low-level language and high-level language. So working with C will give you a lot of insight into computer architecture, and I think it's good for a computer science engineer. So we should be clear, in this series of lessons we are going to learn programming through C. To learn any language we should learn some vocabulary, some grammar. Basically we should have some set of rules, some syntax, some semantics. Of course the rules for a programming language will be much more stricter than rules for a natural language. A programming language cannot be ambiguous like natural language. We will get started with all of these things in our next lesson. We will also write our first C program in next lesson. This is it for this lesson. Thanks for watching.